Welcome back to Next Level Gentlemen with your host, Callum Wren, the podcast where we break down the complexities of the world and elevate your thinking to the next level. If you're new here, welcome. If you're a returning listener, thank you for being a part of this journey. Last week, we started our mathematical exploration by looking at the history of mathematics, tracing its roots from ancient civilizations like the Babylonians and Egyptians to the groundbreaking work of modern mathematicians. Today, we're venturing into the natural world and seeing how mathematics manifests itself, not as something created by humans, but as something inherent to the universe itself. This episode is called Mathematics in Nature, and we're diving into fascinating patterns, numbers, and shapes that are present all around us, from the smallest forms of life to the most massive celestial bodies. We'll talk about the Fibonacci sequence, the golden ratio, fractals, symmetry, and much more. We'll uncover how nature, whether through plants, animals, or even galaxies, seems to follow mathematical principles with a kind of innate precision that we're only just beginning to comprehend. So buckle up, because by the end of this episode, you might never look at the world the same way again. You'll start to see math not as a collection of numbers and formulas, but as a universal language that nature itself speaks fluently, whether it's arranging the seeds of a sunflower or crafting the perfect spiral of a galaxy. Let's get started. One of the best-known examples of mathematics in nature is the Fibonacci sequence. This series of numbers, starting with 0 and 1, where each subsequent number is the sum of the previous two, has fascinated mathematicians for centuries. The Fibonacci sequence begins like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. What's truly incredible is how often this sequence appears in the natural world. One striking example is in the pattern of seeds in a sunflower. If you've ever taken a close look at the center of a sunflower, you'll notice that the seeds are arranged in spirals. These spirals aren't random. In fact, they follow the Fibonacci sequence. Count the number of spirals in one direction, and then in the opposite direction. You'll often find that these numbers are consecutive Fibonacci numbers. For example, you might count 34 spirals in one direction and 55 in the other. This mathematical precision isn't just a quirky coincidence. There's a reason nature adheres to the Fibonacci sequence, particularly when it comes to plants. The arrangement of leaves, seeds, and petals in this way allows plants to maximize exposure to sunlight and nutrients. By following this pattern, a plant ensures that no two leaves or seeds are crowding each other, optimizing space and light absorption. It's nature's way of solving a practical problem in the most efficient manner possible. We see similar spirals in the shape of pine cones, pineapples, and even in the arrangement of leaves around a stem, a concept called phyllotaxis. But the Fibonacci sequence doesn't stop at plants. You can also find it in the animal kingdom, particularly in the spiral shells of mollusks, like the nautilus. The nautilus shell follows a logarithmic spiral, which is closely related to the Fibonacci sequence and the golden ratio, a mathematical constant approximately equal to 1.618. The golden ratio is another key example of mathematics in nature. This ratio, often denoted by the Greek letter phi f, appears in everything from art and architecture to the proportions of animals and plants. What's so fascinating about the golden ratio is that it seems to represent balance and beauty, both in nature and in human-made objects. For instance, the spiral of a seashell grows outward in a way that maintains its shape, all while adhering to the proportions of the golden ratio. This ratio can also be found in the branching of trees, the arrangement of flower petals, and even in the bones of the human body. But it's not just plants and animals that adhere to these mathematical principles. We can see the same logarithmic spiral in the structure of hurricanes and galaxies. Our very own Milky Way galaxy follows a logarithmic spiral, with its arms curling out from the center in a precise, mathematically defined pattern. The beauty of this is that the same mathematical pattern applies to objects that are vastly different in size, whether it's the tiny shell of a mollusk or the enormous spiraling arms of a galaxy millions of light years across. It's this universality of mathematics that is so astonishing. Let's talk a bit more about the golden ratio. as it deserves more attention. This ratio has fascinated people for centuries because it seems to strike a balance between harmony and functionality. Artists like Leonardo da Vinci used the golden ratio in their work, and it's said that the proportions of the Parthenon in Greece adhere to this ratio. But nature figured this out long before humans did. The human face is often considered more attractive if it adheres to the golden ratio. Faces that are well proportioned with eyes, nose, and mouth placed according to this ratio are often perceived as more beautiful. It's no surprise that we instinctively respond to it, given how prevalent it is in the natural world. Symmetry is another crucial element of mathematics in nature. Bilateral symmetry, where one half of an object is a mirror image of the other, is common in many animals, including humans. Think about it. If you draw a line down the middle of your body, the left side is more or less a mirror image of the right side. Symmetry provides balance and stability, which is why it's so common in nature. Animals with symmetrical bodies, like humans, fish, and birds, often move more efficiently as their balanced structure reduces drag and resistance. But symmetry is not just about function, it's also about beauty. Symmetrical faces and forms are often perceived as more attractive, likely because they indicate good health and genetic fitness. But nature doesn't always follow perfect symmetry. Sometimes asymmetry serves a purpose. Take the fiddler crab, for example. Males of the species have one claw that's significantly larger than the other, which they use to attract mates and ward off rivals. In this case, asymmetry gives the fiddler crab a competitive advantage in its environment. So while symmetry is often associated with balance and beauty, nature has a way of using both symmetry and asymmetry to achieve its goals. Now let's shift our focus to one of the most mind-bending examples of mathematics in nature: fractals. A fractal is a never-ending pattern that repeats at every scale, and we see them everywhere in the natural world. For example, consider the branching of a tree. A large branch splits into smaller branches, and those smaller branches split into even smaller ones, and so on. The pattern of branching is self-similar at every scale, meaning the structure of the whole tree is reflected in its smaller parts. Fractals also appear in other areas of nature, from the intricate patterns of snowflakes to the jagged edges of mountain ranges. The coastline of a beach is another excellent example. No matter how much you zoom in on a coastline, you'll find the same jagged, irregular shape repeating itself. This repetition of patterns at different scales is a defining feature of fractals, and it's one of the reasons why they're so effective at modeling complex natural systems like weather patterns, geological formations, and even the human circulatory system. The beauty of fractals is that they allow for complexity from simplicity. A simple mathematical rule can generate an incredibly complex shape, and this is why fractals are powerful in modeling natural processes. Take lightning, for example. The way lightning forks and branches as it spreads through the sky follows a fractal pattern. What's fascinating about fractals is that they're not just theoretical, they're practical too. Scientists use fractal geometry to model phenomena as diverse as earthquakes, stock market fluctuations, and the growth of cities. So, what does all this tell us? It tells us that mathematics isn't just a human invention used to make sense of the world. Instead, mathematics is an inherent part of nature itself. From the spirals of galaxies to the intricate patterns of a pine cone, math is everywhere. It governs the way plants grow, the way animals move, and even the way galaxies form and evolve. Next week, we'll continue our exploration by looking at how geometry has influenced human creativity. We'll dive into the ways mathematical principles have shaped art and architecture, from the ancient pyramids to modern skyscrapers. It's going to be a fascinating episode, so make sure to tune in. Thank you for joining me today. I'm Callum Wren, reminding you to keep leveling up, stay curious, and always seek out the patterns that shape the world around you. Until next time, stay sharp and stay tuned.